Unraveling the new Fermi paradox solution. Why are we alone? From the depths of space, eerie hush rises. The universe should be full of life, but all we've found is a freezing expanse of nothingness. Enrico Fermi posed the question, if intelligent life is common in the universe, then where is everybody? With so, the Fermi paradox was formed. Many solutions to the universe's unsettling silence have been proposed since then, ranging from the pessimistic to the optimistic, with some claiming we are the only intelligent beings in the universe and others claiming advanced civilizations are actively hiding from us out of fear. In this video, we'll look at the history of the Fermi paradox, the different potential answers, and the ramifications for us on Earth. Are we the only ones in the universe? Or are we just too loud? The answers to these questions lay deep within the universe, and the truth may be more terrifying than we can conceive. To discover more, watch this video to the end. Before we get into the paradox, let's first learn about Fermi. Enrico Fermi was an Italian physicist best known for developing the world's first nuclear reactor. He was a clever and imaginative scientist who used his knowledge to develop something never seen before. His work was so outstanding that he is still regarded as one of the finest physicists of all time. In 1938, he was awarded the Nobel Prize in Physics, and his work has impacted numerous other scientists and engineers throughout the years. In addition to his work on the nuclear reactor, he devised the theory of beta decay, identified transuranium elements, and contributed significantly to the development of quantum theory. He also worked on nuclear energy, nuclear weapons, and other physics topics. Fermi's findings helped form our modern world, and his impact will live on for future generations. Fermi was also the one who first put the famous question, where is everybody, and thus began the Fermi paradox. In 1950, this subject was raised during a lunch chat with co-workers in Los Alamos. A cartoon depicting aliens emerging from a flying saucer carrying trash cans stolen from New York City triggered the discussion. Fermi came to the conclusion that interplanetary travel may not be conceivable, may not be worth the effort, or that a technological civilization may not survive long enough to invent interstellar flight. This resulted in the Fermi paradox, which calls into question the possibility of extraterrestrial civilizations. People have been looking for evidence of intelligent alien life, but have found no conclusive evidence that anyone or anything is out there. Several answers have been presented in an attempt to explain this riddle. Some believe we are the sole intelligent life in the cosmos, while others believe sophisticated civilizations are purposefully avoiding us out of fear. Stay tuned to find out about the latest. Let us begin with the potential of ancient civilizations. Have you considered the idea that they are present in our galaxy but are purposefully concealing in order to avoid detection? Hear this Fermi paradox solution. It's known as the dark forest theory. The dark forest theory is like a terrifying story. Consider a large forest full with animals such as lions, tigers, and bears. All of the animals want to be safe, so they keep very quiet so as not to draw attention to themselves. That way, no one can track them down and harm them. That's similar to the dark forest theory. All the different civilizations out there in the cosmos don't want to make any noise or be noticed, so they keep quiet to avoid being hurt by a more powerful civilization. The dark forest theory's mystery and threat is that no one knows what is beyond our own galaxy. Is it possible that there are other civilizations out there, or are we the only ones? Is there a great alien entity hiding in the shadows, ready to strike? Keep an eye out for the most recent offered remedies. The newest bone, proposed by two researchers, suggests that the lack of extraterrestrial visitation is due to a singularity generated by superliner scaling. Their paper was published in the Royal Society Interface Journal. According to the proposed answer, as civilizations evolve, their technical capabilities scale faster than their population, resulting in a singularity in which the amount of resources and energy accessible to a single individual exceeds the total resources available to the civilization. As a result of this singularity, the civilization collapses in on itself, unable to sustain its population level and eventually extinction. According to the researchers, this phenomenon could explain why we have yet to receive signals from extraterrestrial civilizations. If civilizations are prone to collapsing as a result of their own success, there may be a small number of civilizations in the galaxy that have avoided this singularity and are now engaging in interstellar communication. The study's authors went on to recommend that we hunt for civilizations that have managed to maintain balance while avoiding population collapse, resulting in a more sustainable and potentially more populous universe where interplanetary communication is more widespread. While the presented idea is intriguing, it should be noted that it is only one of many possible explanations for the Fermi paradox. More research is needed to validate or deny the singularity idea, as well as more information on why and how civilizations may sustain a steady population and technological advancement. What can we do to quantify the Fermi paradox solution and ascertain if we are alone in the universe? Is there a way to assess the likelihood that we are not alone? You're in luck since scientists have already done their homework. Many astronomers and astrobiologists know the name Frank Drake when it comes to the investigation of extraterrestrial life. Drake devised an equation in 1960 to calculate the number of detectable civilizations in our galaxy. This essential equation is now known as the Drake equation, and it has become one of the most important tools for estimating the chances of discovering life beyond our planet. Frank Drake's equation starts with a list of 7 variables that potentially affect the number of detectable civilizations in the Milky Way. These include the rate of star formation, the fraction of stars with planets, the average number of habitable planets per system, the fraction of habitable planets that develop life, the fraction of planets with life that evolve into intelligent civilizations, the fraction of intelligent civilizations that develop detectable technologies, and the average time it would take those civilizations to produce such signs in years. When these variables are entered into Drake's equation, it can calculate the number of detectable civilizations in our galaxy. However, these figures are not yet completely precise, making it difficult to know where to seek. Drake's equation has been used by astronomers and astrobiologists to increase our understanding of the possibility of finding extraterrestrial life since 1960. The equation has been used to investigate the possibilities of interplanetary transport as well as the possibility of interstellar communication, in addition to being valuable in the hunt for extraterrestrial life. This argument is similar to the Fermi paradox, which asks that if intelligent civilizations exist in the cosmos, why haven't we found any proof of them? Scientists have proposed several answers for this contradiction, including civilizations simply refusing to interact or our civilization being too young to join the galactic society. This paradox, along with the Drake equation, has served as the foundation for numerous SETI, search for extraterrestrial intelligence, programs which seek to detect radio transmissions from other civilizations in the universe. SETI experiments have been running since the 1960s and continue to look for signals of intelligent life in space. The Drake equation, of course, has limits. Because the values for the 7 variables are mostly unknown, the equation is only as reliable as the data used. Drake's equation, on the other hand, has become an indispensable tool in the scientific community, and its impact on our understanding of the cosmos and the potential for finding other forms of life is enormous. Regardless of its shortcomings, Frank Drake's equation has had a significant impact on how scientists and other interested parties think about the possibility of extraterrestrial life. Drake's equation will remain an important component of the discussion as we continue to discover more about our cosmos. Finally, the Drake equation and the Fermi paradox demonstrate that, while life beyond Earth may exist, the chances of encountering it are remote. But this does not mean that we should abandon the hunt. For many, the prospect of uncovering an extraterrestrial civilization is a worthwhile goal. The universe is enormous, with an estimated 100 billion galaxies and more than 10 trillion stars in our own Milky Way alone. With such enormous life potential, it's tempting to imagine that life must exist elsewhere. In fact, the concept of extraterrestrial life is immensely popular among the general public and has long been a fixture in science fiction. Even mainstream science has speculated on the possibility of intelligent life outside in our galaxy, even developing the Drake equation to help predict the number of such civilizations. But what if, despite all of these exciting possibilities, we are truly alone? Such an idea has numerous consequences that, in principle, could be frightening. After all, if we are genuinely alone, it implies that there is no one to assist us in times of need, no one to save us from ourselves. There will be no alien race to solve all of our issues. On the other hand, such a revelation might instill a revitalized sense of purpose and motivation in humanity. Knowing that we are the only ones out there may give us the confidence to solve our own difficulties. It may help us appreciate our planet's unique beauty and take better care of it. It has the potential to bring our species together in ways it has never done before, with the common objective of ensuring our own survival. Nobody knows for certain whether we are actually alone in the universe. One thing is certain, finding the answer is a thrilling proposition with far-reaching ramifications for our species and our role in the cosmos. For years, the Fermi paradox has captivated minds, yet it remains as perplexing as ever. We simply have theories and hypotheses with no real proof to back them up. As a result, we must wait and see what the future brings. A key question lurks behind the universe's silence. Why hasn't anyone or anything replied to our cries for contact? Could advanced civilizations have just transitioned to another dimension of existence? Could intelligent life simply be too scarce in our cosmos to be detected? Could intelligent life be purposefully attempting to hide from us out of fear? It's difficult to say, but the Fermi paradox will haunt us until we uncover the ultimate solution. Let us know what you think. Which of these options do you believe is more likely to be true? Leave a comment below. We want to know what you think. This video has come to an end. Thanks for watching, and don't forget to like and subscribe to our channel, as well as switch on notifications to remain up to date on our most recent videos.